For decades, this thing was basically a ghost story, right? A monster that science had supposedly banished for good. But it's back. An old enemy is marching north, and what we're about to dive into is this incredible story of biology, human ingenuity, and a war that's being fought all over again.
So how on earth does a single fly become a billion-dollar threat? It sounds like a simple question, but let me tell you, the answer is, well, it's pretty terrifying. And we are not talking about your average, everyday housefly. Oh no. We're talking about a parasite that poses a catastrophic risk to our livestock, to our wildlife, and yeah, even to us.
Okay, so let's meet the villain of our story. This is the New World screwworm. Its scientific name is, and I love this, Cochleomya homnivorex. That last part, homnivorex, literally translates to man-eater. And believe me, as we're got to find out, it has definitely earned that name.
All right, section one, the monster. To really wrap your head around this threat, you have to understand what makes this thing tick. This is not your average pest. It's what scientists call an obligate parasite. Fancy term, right? All it means is that it cannot survive without a living, breathing host. Its entire way of life is, well, it's pretty gruesome and incredibly specific. And here is the key, the absolute core of what makes it so horrifying. The term is traumatic myiasis, and the key phrase here is healthy living tissue. See, most flies they're drawn to decay, to dead things, not the screwworm. It actively seeks out life. Any tiny little cut, a tick bite, heck, even the brand new navel of a newborn calf, that's an open door, an invitation for this parasite. And this is exactly why they're called screwworms. It's not just a name, it's a description of what they do. The larvae, their little bodies are covered in these spines that look just like the threads of a screw. So if anything disturbs them, they don't retreat, they burrow deeper, literally screwing themselves into the flesh of their host. And it gets worse. That wound they're creating, it acts like a beacon, attracting even more female flies to lay their eggs. It's this horrific, expanding infestation that can kill a full-grown steer in less than 2 weeks. Just incredible.
So what you're looking at here, this is basically the engine of all that destruction. A single female can lay hundreds of eggs, and what we're seeing here are the results of that. Larvae being studied in a lab. It's just a stark reminder that this whole biological war is being fought on two fronts, the microscopic and the absolutely massive.
Okay, so if this thing is so terrifying, how did we beat it before? I mean, we did beat it, right? Well, the answer wasn't some new pesticide. It was something way, way smarter. It's actually one of the greatest success stories in the history of applied science.
It's called the sterile insect technique, or SIT, and it's basically a biological Trojan horse. It is genius in its simplicity. Here's how it works. You mass produce millions of these screwworm flies in a lab. Then you blast the pupae with radiation to sterilize them. Then you release just the sterile males out into the wild. Now here's the kicker. Female screwworms only mate once in their entire lives. So if you just flood an area with millions of these sterile males, the odds are overwhelming that a wild female is going to mate with one of them. The result? She lays unfertilized eggs. No new generation. The population just crashes. Brilliant. And the scale of this effort? It was and still is just immense. What you're looking at is the production facility down in Panama. For decades, this place has been the frontline defense, a kind of biological fortress, churning out over 100 million sterile flies every single week, just to maintain a barrier to keep them from coming back.
And you know what? It worked.
It absolutely worked. By 1966, after this massive, coordinated campaign, the United States was officially declared screwworm-free. I mean, what a monumental victory. For more than 50 years, half a century, we lived in a world where this threat was just a memory. Until now, that world is gone. The decades of peace, they're over. That biological barrier we built, our first and last line of defense, it's been breached. Just look at the speed of this thing. I mean, it's breathtaking. In July 2023, Panama goes from like 25 cases a year to over 6,500. By late 2024, it's in southern Mexico, forcing the U.S. to ban livestock imports. Then, by late 2025, it's detected just 70 miles from the Texas border. And by January 2026, confirmed cases in the Mexican state right next door. The threat isn't distant anymore. It's here. It's imminent. So what's at stake? Well, how about $2.3 billion with a B? That's the estimated savings every single year that this barrier program provides to the U.S. livestock industry. It's a multi-billion-dollar shield, and right now, it's on the verge of shattering. And this isn't just about livestock, not by a long shot. Just look at the difference on this chart. It's staggering. Before 2023, human cases were so rare they were almost non-existent. But during this recent resurgence, that number has shot up to over 1,200 reported cases. This isn't just an agricultural problem, it's a public health crisis, and it's unfolding right now.
So the old defenses have failed. The wall has been breached. So how do you fight a 21st century invasion? You have to deploy a 21st century arsenal. This is the new war.
All right, so the first big upgrade is actually to the sterile insect technique itself. See, the old method was a little inefficient. It released both sterile males and sterile females. Now, why is that a problem? Well, those sterile females would still compete with the sterile males for the attention of the wild females. It just cluttered the battlefield. The new method is way smarter. It uses something called a transgenic sexing strain. Basically, it's genetically engineered so that only the males survive to be released. It's a much more targeted weapon, and it essentially doubles the effectiveness of every single release and slashes the costs.
But what if you could take it a step further? What if you didn't need to release millions and millions of flies every single week? What if you could just release a handful and have them do all the work for you?
Well, welcome to the world of CRISPR gene drive. This is some serious next-gen stuff. This isn't about overwhelming the population with sterile flies anymore. This is about rewriting its genetic code from the inside out. Scientists can use CRISPR to insert a gene that basically makes all the females infertile. And here's the crazy part. They design that gene to be passed down to almost all of the offspring, not just half, so it spreads through the population like wildfire. You release just a small number of these gene-edited flies, and they could cause the entire wild population to just eliminate itself. It is a true biological silver bullet. And of course, the U.S. government is taking this threat with the utmost seriousness. The USDA has launched something called the Grand Challenge, and it's basically a $100 million call to arms. They're pouring money into projects to find the best and brightest ideas. Brand new traps, new treatments, and all the tools we're going to need to win this fight.
And of course, winning this new war means knowing exactly where the enemy is at all times. So the new front line isn't just about releasing flies from a plane anymore. No, it's a full-on high-tech surveillance network. We're talking about using drones for mapping terrain, using artificial intelligence to analyze data from traps, and even using satellites to monitor environmental conditions so we can predict where the screwworm is going to strike next.
Which really leaves us with the ultimate question, doesn't it? The biological wall that we built half a century ago, it's crumbled, it's gone. And now we're placing all our bets on technologies like CRISPR and AI, stuff that was pure science fiction back then. So can 21st century genetics win a war that our 20th century walls have lost? The battle is on, and honestly, the future of North American agriculture and wildlife is hanging in the balance.